Hey guys, this is Mr. Pasco with the first lesson in Chapter 5 on networks and Lesson 1. So if you go to the OneNote, there is Networks Chapter 5, and if you look at that page, it has some work program and some notes which we might look at another time. It also has some notes for the chapter, which are reasonable sort of notes. So you can look at those as well and copy and paste things from that into your own notes. All right, now networks has a lot of definitions and a lot of things to learn, and so you need to keep really good notes for this chapter. Networks are used in electricity distribution networks, mobile phone networks, there's neurological networks inside your brain, and animals as well, road networks, distribution networks, computer networks, obviously using the internet, there's social networks, which you all know about. There's also terrorist networks, drug cartel networks. They have miles and miles of pipes and things in oil refineries and chemical plants. They're all involved with a network as well. And so many other things as well. Airlines, their flights that they do to different cities is all a big airline network. And there's the road network and so on and so on and so on. We could talk forever about that. But let's just get across and have a look at Passie's World of Mathematics. And there's a link there. Just something on networks in Sydney. They have fabulous brand new trains, clean stations, no graffiti. It's so much better than Melbourne. And so is their rail network, because Melbourne has this kind of bike spokes coming out in all directions from a central hub. This is called a hub and spoke network, which is a real problem, because if you want to get from, say, Berwick to go to the beach at Frankston, you've got to go all the way into Caulfield and then all the way back out to Frankston. And a lot of places you have to go right into the city or into Richmond and then go out again to get somewhere else. If you go to Sydney and use their rail network, you should go to Sydney sometime. It's a fabulous place. Notice how they have all these loops there, so that if you want to go from here over there, you don't have to go all the way into the city and back out again. You can just use this train line, which they have built now, over to there and get across straight away. So with these loops, it makes getting around a lot better, and you're not always going into the city and back out again, all right? So you can have loops in networks, and that improves things. Now, on OneNote, let's get across to Lesson 1, which is right here, vertices, edges, and regions, all right? So these are the first things we have to learn about, vertices, edges, and regions. And there's some things here on OneNote which you can look at, but let's get across and just have a look at a basic network. This particular one here. So notice we've got these dots. So on each dot we have a letter. Now the dots are called vertices. So let's make some notes here. So we've got vertices. I'll try and write neatly. Vertices they're called. If you've just got one of them, it's called a vertex, but if you've got more than one, it's called a vertice. Now vertices are your dots, okay? So if we count up how many of these dots there are here, there's A, B, C, D, E, F. So we've got 1, 2, 3, 4, 5, 6. Let's just check again. We've got 3 dots up there, 3 down here. So there's 6 vertices altogether in that particular network. All right, connecting the vertices together, let's pick another color, like maybe this one. All right, now connecting the vertices together, you have these lines. So this line here connects B and F, and those lines are called edges. So this is all on the OneNote and in your book as well, and in those Word document notes on the chapter as well. So the next thing we have to deal with is edges. So we've got vertices, and they were the dots. So maybe we should make a note on that. Let's just go back here. So vertices are your dots. Basically, you'll notice usually they're labeled with letters. So we'll just put that down. Usually there's letters. And sometimes another name for them is that they're called nodes in the network. N-O-D-E. Nodes. So they can be called nodes as well. All right, let's get back to edges, because that's what we're working on, the edges. All right, now the edges they're the connector lines, okay? So we've got one going from A to B, so that's one edge. We've got one to B to F, that's 2 edges. 3 edges there for FE. E goes across to B, so that's 4 edges. A is connecting up E, that's another line, that's 5 edges. We've got a line here that's 6 edges, 7 edges, 8 edges for D going to C, 9 edges here for A going to D, and B going to D, I believe, is our final edge. We got 10 altogether. So let's check that out. We've got 1, 2, 3 on the bottom here, 4, 5, 6, 7, and we've got an 8, and we've got a 9 and a 10. Okay, so there's 10 edges altogether. All right, the next thing is something called regions. All right. Now we might get a highlighter pen for this one. Now what a region is see these enclosed areas, like there's a triangle here, you can color that in, and that's called one region. And then there's another triangle kind of enclosed here, so that's 2 regions. So regions are the areas inside the edges. So we've got another one there, another triangle, 3 edges, 4 regions, sorry, and we've got another one here in the middle. So we've got 5 edges. And there's always an extra edge because you can color around the outside of the object and that, or the network, and that counts as the 6th edge, the extra edge. So often it's more than what you think. If you color in with your pencil or whatever, there's 1, 2, 3, 4, 5 different triangles we can color in to make regions or faces, but there's also the one around the outside as well. Okay, so when we're talking about regions, which are those areas, so regions, on this particular diagram we have, as we discussed, we've got 1, 2, 3, 4, 5, 6 regions. 6 regions altogether. Okay, now there's one more thing I think we have to learn for lesson 1, and so let's just erase all this out quickly. There's another thing called degrees. Okay, so that's our next thing to deal with, degrees. So let's pick a blue color for this. No, maybe we won't pick blue, we'll pick a green. Degrees. Okay, now how degrees work is, here's vertex F, and coming out of it we've got 1, 2 connector lines, all right? 2 edges come out of F. So the degrees for F is that F would equal 2. It's got a degree of 2. All right, so degrees equals how many lines you've got. All right, and they're our connector lines, so they're called connector lines. I wish I could write faster. I'm not going to use the pen because I'm not real great with that. Connector lines, which are also called, of course, your edges, is the official name for them in networks. All right, so it's how many are coming out of each vertex. So it's your connector lines, edges, out of a vertex. Hurry up and write faster, vertex. All right, so you have to count for each dot, if you like, how many sticks are coming out of it. So F's got 2, E has 1 line, 2 lines, 3 lines, 4 lines. There's 4 edges that come in and meet at E. So E connects up 4 different edges, so E has 4. So let's try and write that as neat as we can. E equals 4. C has 1, 2, 3 on it. Okay, so that's got 3. Let's just mark them on here. 4. F's got 2. B has 1, 2, 3. Okay, so it's got 1, 2, 3, 4. So there's eraser tool, eraser tool. Get rid of that little guy. Okay, so there's B has 1, 2, 3, 4 on it. That's got 4. So we say B is of degree 4 because it has 4 edges connecting into it. D is of degree, is what we say in networks. It's got this guy here going across the bottom. So it's got 1, 2, 3, and A in the middle there has quite a few. It's got that one, that one, that one, and that one. So it's got 4 connectors coming into it. So it's got degree 4. So if we add all that up, we'll just do total. Work out the total degrees by adding all those little numbers up there. we get 4 plus 2 is 6, plus another 4 is 10, 14, 17, 20. Just double check, 3 and 3 is 6, and the 4 in the middle is 10, plus another 6 there is 16, plus that 4 right there is 20, so we get 20. Now what happens is there is a mathematical relationship between the total degrees or the total connectors you've got coming into vertex dots and the total edges you've got, the edges lines. So if you've got 10 edges, you'll get 2 times the number of degrees. Kind of like because you need a line to connect 2 dots. But anyway, there is some maths that they tell you in this lesson and will get you to do, and that is that the edges, and they do it back to front, which I think is silly because it just makes it harder to understand. The edges, how many edges you've got equals half your total degrees. I would rather look at it that once you've got your edges, you would say edges are 10 and you would double that and say, okay, I've got 20 total degrees if I add up all my degrees up. But I like to do it the other way, edges equals 1/2 the total degrees. Okay, so that's pretty much all the learning for this lesson. You've got to know what edges are, what regions are when you colour in the triangles. These degrees, which is the number of sticks or the number of connector edge lines coming out of a dot, and the total number of those lines coming out of a dot when you add them up will be double your number of edges in a network. All right, so let's have a look at an example here of the sort of question they want you to do. So we've got a map there of a park, all right? So they're saying to make a network diagram for that park. All right, so you just take the dots. These are gates in the park, by the way. So there's A, E, C, B, and D, all right? Now we do have some sort of connector things here and here, but they don't have dots on them. They don't have gates. So they're not actually vertex connection points. It just means that if you want to get from A to E, you can kind of go in this straight line, or you can go a roundabout way from A to E. You can just walk along here, then bend down to E. But that's still the same sort of direct connection between A and E, because you didn't go through another vertex dot while you're doing that trip or that path. You just went from A straight along, not stopping anywhere or anything, to E. So when we draw that, we have to draw A to E straight line for this outside edge one. But then because we had this other curvy one that also connected A and E directly without stopping at any vertexes in between, we just draw another curved line like this, all right? So there's 2 actual connectors between A and E. Now, if you're looking at E and D, we've got this straight line connector here, so we can connect E and D with a straight line. That isn't too straight, is it? So let's have a go at fixing it. Eraser, eraser. Let's get back on that. Let's try and get that a bit straighter. So E to D, we've got a straight line connector, but you also have this curvy one. You can go from E along there and curve around and get to D. So that's another sort of continuous connection to D, but it's kind of a curvy one rather than going in a straight line. So again, we have to draw one of those loops for that. Now, I think the rest is all straight lines. You can go straight from A to B. So we just put A to B as a straight line there. B to C. It'd be much better if we had a ruler here, but we don't have electronic rulers. B to C and C to E. We do in Adobe products, actually, but you can do dot-to-dot straight line points, but not in this, so I'll have to up my skills. And we do have a... Now, for D to B, again, that is a continuous connection from D to B. So there is a connection from D to B, and this is the weird bit. That path curves, but on the diagram, they draw it as a straight line. Go figure. And you have got a curvy continuous path going from D round to C like this. But again, I think on the answer diagram, they just put it as a straight line. But if you do it as a bit of a curve, that's all right. So they're basically all the connections. So we should have, here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 edge connectors. So we've got 4 around the outside. We've got these 2 curvy ones. We've got 3 other ones in the middle. So we got 5 and 4 is 9. So if we wanted to say how many edges there were on that, if they were asking that question, the number of edges or direct connections between those vertex gates in the park is 9. All right, now if we were asked how many vertex there are, or how many vertices there are, we've got the A, we've got the B, we've got C, D, and E. Okay, so that gives us 1, 2, 3, 4, 5. So vertices would be 5. Okay, and if we were going to colour in regions, we'd have one in here we could colour in. That's 1, 2, 3, 4, 5 different regions. Plus, of course, remember you can always colour around the outside to make that extra region. So that's 1, 2, 3, 4, 5, 6 regions altogether in that. So if they ask you the regions, regions are sometimes called faces. If they want to know the regions or the faces, that would be whatever we said. It just was 1, 2, 3, 4, 5, 6, I believe. And remember, edges can also be called nodes. And the other thing is that they don't call these diagrams like that one we just drew. They don't call them network diagrams a lot of the time. They call them, actually, they call them graphs because you've got lines and graphs. Now I'm just going to rub out those regions we did because they're not really part of the answer. Now I've rubbed out a line, of course. Let's get that line back in. Okay, so the answer was just drawing the connector lines, the edges between it. And that would be that one done. All right, now this one here, they're asking you to prove that the number of edges you've got. Well, let's do that first because that should be pretty easy getting the edges. So let's just work them out. We've got 1 edge, 2 edge, 3 edges, 4 edges, 5 edges, 6 edges, 7 edges, and another one here, 8 edges. Okay, because there's 5 around the outside. 1, 2, 3, 4, 5 around the outside, and there's 1, 2, 3 in the middle. So 1, 3 is 8. So edges equals 8. Okay, so that was the easy bit, getting the edges. Now, getting the degrees takes a bit more work, and just so it's not so confusing, I'm going to actually rub out those sort of things we drew to count the edges quickly. So there are 5 around the outside and those 1, 2, 3 kind of sticks or connector lines in the middle. Now, when we're doing the degrees, let's get back onto doing degrees. Okay, with the degrees, it's how many are there's coming out of each point. So A's got 2 connector lines coming out of its degree is 2. B's got 1, 2, 3 edge lines coming out of it, so it's a 3. C's got 1, 2, 3 as well. Its degree is 3. F's only got 2, so it's got a degree of 2. E has 1, 2, 3 connector lines, so its degree is 3. And D in the middle has 1, 2, 3 connector lines coming out of D. So D is also a 3. So if we do, they say sum of degrees, so we need to work out the total. Okay, now if we add all of those up, we've got, 2 plus 3 plus another 3, dot, 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 and so on. Let's just fast track that. We've got 2 and 3 is 5, and another 2 is 7, and 3 makes 10, 16, or 3, 6, 8, 13, 15, 18. All right, good. That doesn't work. Let's do it. We've got 1, 2, 3, 4 threes are 12, and 14 and 16. Just one more time. 5, 7, 10, 13, 16. Okay, so it's definitely 16. And again, notice that that total degrees has come out as 2 times the edges. Okay, so total degrees has come out as 2 times the edges. All right, in your book, they kind of do this long working out and stuff, but you don't really need that. We have proved that if we took half the sum, if we took half the degrees total, if we took half of 16, we will get 8, which is the edges, so that's all good. One more we'll do is just question 1. They've got this picture of a house, and they want you to draw a network diagram for it. So each room is a dot or a vertex on the diagram. So over here, we've got bathroom 1, bathroom... Oh, why didn't I just put bath 1? So I'm crazy. Bathroom 1. Okay. Making mistakes here. Let's get rid of that too. Okay, so that's bath 1. And then here we've got bedroom 1. So we just put B1. In the middle of the house, we've got the lounge room. Then we got the TV room down here. Then to the left of that, we've got another bedroom, bedroom 2. So put a little dot for that. No, that's bathroom 2, actually. Oh, well, let's get that eraser. Getting real good with this eraser, eh? Right, draw. Okay, so that was bath 2. Bath number 2. And then over here, we'll have BR2. All right, now what connects those rooms together is simply the doors we have. All right, so we've got bathroom 1, it connects up to bedroom 1 by this door, so there's a direct line between them. Then from bedroom 1, you can go through this door to the lounge room. All right, so you can go into the lounge room, so we just connect that. From the lounge room, this door here will take you into the TV room. There's no door to actually go from the TV room into the bathroom. There's no door there, so you can't draw a line here. You have to go back into the lounge room and go through this door here if you want to get to the bathroom. So that one goes like that. And there's a door over here to get to the bedroom. So again, it's one of those kind of hub and spoke networks like the Melbourne train network is. All right, now the questions you have to do are 1 to 5. So we've done the bedroom 1. There's one here that's kind of paths through a park thing like that example we did. And there's questions 3, 4, and 5. Okay, they're on pages 195 to 196 of your book. So hopefully this video wasn't too long. And that's lesson 1 done on networks. And we'll see you in the next lesson.